In a world where self-driving cars are no longer confined to our imaginations, challenges loom larger than ever. These autonomous vehicles promise to reshape our urban landscapes. But can they truly navigate the complexities of human behavior? Just last month, one major automaker, faced with public skepticism, reported a 30% increase in safety incidents during testing, revealing that despite the technology, humans still pose an unpredictable variable. This dynamic uncertainty raises a critical question. Can algorithms ever fully replicate human intuition in driving? The technology behind autonomous vehicles is rooted in complex AI systems that depend on massive datasets for learning and decision-making. LiDAR sensors, computer vision, and neural networks work together to interpret the driving environment in real time. The historical journey toward today's self-driving technology began over a century ago, but it wasn't until the 1980s that the first significant strides were made. In 1986, Carnegie Mellon University launched the NavLab project, which saw a van equipped to navigate across the Virginia countryside. The vehicle relied on rudimentary sensors and manual input, a far cry from today's sophisticated systems. Fast forward to 2009, Google's self-driving car project took shape under the leadership of Sebastian Thrun, bringing the ambition of fully autonomous driving into public consciousness. The first successful test runs on public roads in California were a striking sight: an unassuming Toyota Prius gliding silently through traffic, driven by lines of code rather than a human. However, the path to full autonomy is fraught with hurdles. As these vehicles navigate daily commutes, they encounter scenarios that require rapid adaptation. Imagine a bustling city street. A child darts into the road to retrieve a lost soccer ball, while a dog suddenly breaks free from its owner's grasp. The car's algorithms must make split-second decisions, weighing the potential outcomes of every action. During a recent test, a leading self-driving car struggled to predict a cyclist's sudden lane change, a moment that illustrated the limitations of current algorithms in real-life situations. The vehicle's sensors detected the cyclist, its advanced software calculated possible outcomes, yet it hesitated, caught in a web of probabilities. In that critical moment, human intuition would have stepped in, making an instinctive choice that a machine could not. These challenges are compounded by external conditions that further complicate the driving landscape. Erratic weather can impact sensor performance. Heavy rain can obstruct visibility, and snow can quickly obscure lane markings. In 2021, a self-driving car in a snowstorm faced difficulties detecting road boundaries, leading to a temporary halt in testing. The engineers on site were visibly frustrated, knowing the progress they had made could be undone by something as simple as a weather event. "We're building these cars to be robust against all conditions," one engineer remarked, "but nature has a way of reminding us of our limitations." The implications of this technology reach beyond mere safety. The rollout of self-driving technology affects employment, urban design, and even insurance models. Millions of driving-related jobs are at stake. Estimates suggest that up to 3 million truck drivers could find themselves out of work within the next decade due to automation. The impact on the workforce is palpable, as entire communities built around the trucking industry face an uncertain future. In towns where truck stops and repair shops thrive, the prospect of widespread automation can feel like an impending storm. Moreover, cities may need to rethink infrastructure, adapting to vehicles that communicate with each other but also rely heavily on high-speed internet connectivity. Imagine a future where traffic signals sync with autonomous vehicles to optimize traffic flow, but consider the costs to update aging infrastructure and ensure equitable access to this technology across urban and rural divides. The promise of fewer accidents and more efficient traffic flows stands in stark contrast to the societal upheaval that may follow. As urban planners envision roadways lined with smart traffic systems and vehicle-to-vehicle communication, they must also grapple with the displacement of workers and changing public transport dynamics. The real challenge lies not just in perfecting the technology, but in addressing the wider ramifications it brings to our communities. Ethical considerations surface as algorithms must be programmed to make life and death decisions. Who is responsible when an autonomous vehicle is involved in an accident? As the technology evolves, these questions will demand answers that balance innovation with social responsibility. The journey toward autonomous driving is not just a technological revolution. It is a societal transformation that will redefine our relationship with mobility, our urban environments, and the economy. As we stand on the precipice of this change, the road ahead is both exciting and fraught with challenges, leaving us to ponder. Can we collectively navigate this new terrain?